Welcome to the online lecture series on the course 8051 microcontroller. In this video lecture, we shall discuss uh, compare jump not equal to instruction, which is a conditional branching instruction. We have three forms of it: CJNE, A, direct, relative address; CJNE, A, hash immediate data, relative address; CJNE at the rate of RI, hash data, relative address. Okay, I shall be explaining the first one. The other two are self-explanatory, except that the destination and the source are different. Okay, so what does this instruction do? It compares two operands. Okay, so in this case, those operands are present. One of the operand is present in accumulator, and one of the operand is present in a direct RAM address. In this case, one of the operand is present in accumulator, and the other operand is an immediate data which is specified along with the instruction. In the third form, one of the operand is in memory, which is pointed by R0 or R1, and one of the operand is the immediate data. Okay, so we shall discuss in detail CJNE A, direct, relative address. Okay, relative address is nothing but the label where you want to jump or you want to branch. Let us see this. CJNE, it stands for compare and jump. When you have to jump, when it is not equal. Okay, now compare. What are you comparing? You are comparing the contents of the destination with the contents of the source. Okay, and what you should do after comparing? You have to branch. Okay, and where is the branching address? Here is the branching address. And when should you branch? Only when the contents of the accumulator are not equal to the contents of the RAM address being specified here. Okay, so if these two are not equal, then you make a branch. Okay, basically compare instruction is similar to a subtract instruction, except the difference is that in subtract instruction, after subtraction, the result is stored back in the destination, whereas in this case, subtraction comparing is also done by subtraction, but the thing is the result is not stored back to the destination, that is the accumulator, but the flags are affected. Okay, let us see that. Now let us see the description. The contents of the source byte, that is the direct address in this case, and the destination byte, in this case it is accumulator, are compared. If they are not equal, it jumps to the target address being specified here. Okay, now, and the most important thing is the contents of destination is not altered. Okay, but the carry flag is affected. How it is affected? As we have seen in case of subtract instruction, if destination is less than the source, so in this case, if the contents of the accumulator is less than the contents of the RAM address being specified, then the carry flag will be equal to 1. If the destination is greater than the source, then the carry flag will be equal to 0. What can be the target address? As I have said, all conditional branching address, the target address will be within minus 128 to 127 bytes of the PC. And the only flag affected will be the carry. Okay, so let us see this with by an example. Okay, how this compare jump and not equal to instruction works. Okay, first let us understand this, then we shall write a small program to understand the working of compare jump and not equal to instruction. Okay, So let me move some data, move a comma hash 40h. Okay, and I will stick an RAM address 30h hash 20h. Fine. Now what am I doing? Compare jump not equal. What I'm comparing? Contents of accumulator with the RAM address. Then you jump, say next. Okay, and most of the time the branching address will be immediately after the compare instruction. Okay, so let me write it here. This is only to understand the instruction. And now in this case, if you see, accumulator has got 40h, RAM address has got 20h. So definitely the contents of the accumulator are greater than 30h. So in this case the carry flag should not be set. Now let us see that. Carry flag is 0 now. Accumulator has 40h and the memory location 30h has got 20h. Okay, now you see, after comparison, two things you should notice. One is, after comparison the contents of the destination are not altered. Okay, secondly, the carry flag is affected. In this case, since the contents of the accumulator is greater than the contents of the RAM location specified, carry flag will be still 0. So if you see, accumulator still contains 40h. So the destination content has not been altered. And carry flag is also equal to 0, indicating that the contents of the accumulator are greater than the contents of the source. In this case, it is the RAM address. Okay, let us do the reverse of it. So I will make this 20h and I will make this 40h. Let me compile. So accumulator contains 20h, RAM contains 40h. Now after this, you see the carry flag. As you can see, carry flag has become 1 because the contents of the destination is less than the contents of the source. Okay, that's why, since they are not equal, it has branched to an address which is specified here. Okay, now let us take a case wherein both the contents are same. Okay, both are 20h. I will write increment some dummy instruction R0 and I will say yes jump last. Okay, these are simple dummy instructions. You need not worry about the logic here. Now in this case, what I am doing, understand properly. Okay, now so this compare instruction compares the contents of the destination with the source. Only if they are not equal, it branches to the address being specified here. Okay, that is here. But if they are equal, branching is not done and the execution continues as usual. So in this case, since both the content are same, so it should not branch, but it should come here. And after this, it should go to the last instruction. Okay, let us see that. Sorry, some error. If there is any error in the program, you cannot debug the program. You need to see. Accumulator contains 20h, RAM address also contains 20h. Carry flag will be 0. Now let us execute this instruction. Now accumulator contains 20h, the RAM location also contains 20H. So since they are equal, this condition will be false. Okay, because this condition will be true only if they are not equal. But in this case, both are equal. That's why it will not branch to this branching address, but it will execute the instruction immediately after this. So if you see, it has not branched. Why? Because the contents of both these are equal. It will execute the following instruction and it will end the program. Fine. So that's about the compare jump not equal to instruction. Okay. So quickly we shall write one more program to understand this better. Okay. Let us say write an ALP to compare contents of accumulator with 30H. Okay. Then if contents of accumulator is greater than 30H, then put FFH in register B. Okay, then but if the contents of the accumulator is less than 30H, that is the contents of 30H, sorry, this is a memory location. Then let us put EH in register B. This is the question. Okay, so you have to compare. Okay, now where is the data? The data is in accumulator. So let me move some dummy data. Move A comma hash 40H and move 30H comma hash 35H. Okay, you can put any data. Okay, now after this we have to compare these two instructions. So I will write CJNE A comma 30H. Okay, then jump to next. Okay, now what is important is, if you want to know whether the contents of the accumulator is greater or lesser than 30H, we have to check the carry flag, because only carry flag tells you whether the contents of accumulator are greater than 30H or less than 30H. If the contents of the accumulator are greater than 30H, then carry flag will be equal to 0, and if the contents of the accumulator is less than the contents of 30H, then the carry flag will be equal to 1. Okay, so in this case, whenever we write the compare jump not equal to instruction, the decision is taken based on the carry flag, because CJNE affects only the carry flag. That's why whenever we write the label, most of the time it is immediate to the instruction, that is followed by the CJNE. Here we will check the carry flag, either use jump on carry or jump on no carry. It depends upon you. Okay, so let me use jump on carry. Okay, what does jump on carry mean? After this comparison, if there is a carry flag being set, what does it mean? It means contents of accumulator is less than 30H. In that case, what should I do? I should put EEH in register B. Okay, so I will say jump on carry to N1, and N1 will be somewhere here. And what should I do at N1? I should put EEH in register B. So what I will do, move B comma hash 0 EEH. Okay, that's the first case. But if this condition is false, what should I put now? I will put move B comma hash 0 FFH, because if the contents of the accumulator are greater than 30H, then in the question it is mentioned that we should put FFH in register B. Then I should end. So that's why I don't want this instruction to be executed after this. So I will say sjump here, and I will write the forever loop. Okay, Let us understand this instruction. Let me compile this first. Okay. Okay. In the accumulator, I have 40H. In memory location 30H, I have 3. So definitely, accumulator contents is greater than the RAM location. So you expect, what do you expect the carry flag to be? So the carry flag, first of all, they are not equal. So it will branch to the branching address which is mentioned. Second, it will affect the carry flag. In this case, the carry flag will be equal to 0. So it has come now. So carry flag 0 indicates that the contents of the accumulator are greater than 30H. So jump on carry, this will be not true. So in that case, it will not branch to N1, but it will execute the next instruction. So that's why you can see move B comma hash FFH will be executed, and then it will go to the last instruction. Fine. Let us do the opposite of it. Let me put 10 here and 50H here. Let us compile this. Now in this case, accumulator contains 10H and memory location 30H contains 50H. But in this case, so, and again, the source and destination are not equal, so it will branch to the branching address. Okay. And what about the carry flag? Carry flag will be equal to 1 because the contents of the accumulator are less than the contents of the RAM location specified. As you can see, carry flag is equal to 1. So since carry flag is equal to 1, this condition will be true. Okay, so this is jump on carry. So since carry flag is equal to 1, it will jump to the address which is specified here. So it will come here, and if contents of accumulator is less than 30H, what are we supposed to do? We are supposed to copy EEH in register B. So that's why we are copying EEH, and register B contains EEH. Fine. So that's about the compare jump not equal to instruction. To summarize, it compares the contents of destination and source. If they are not equal, it jumps to the address specified. After this, it is the responsibility of the programmer to check for the carry flag. Fine. Similarly, you have two more instructions. The working is same except that the operands are being mentioned at by different addressing modes. Okay, those two instructions you can study by yourself. Fine. Thank you.